So let's continue with some more examples. So the first step says to reduce all radicals, so we need to do that first. But because there's a whole lot of coefficients here, we have the x squared coefficient, the negative 2x, the 4y, and this negative invisible 1, I am going to go ahead and drop those down right now. So that when I reduce my radicals, I don't forget to do that, to bring down those values. So 18y can be broken down to 9 times 2 times y, 3, 3, 2, and y. I'm looking for groups of 2 this time because it's a square root. So this 3 gets to go out, and the 2y stays inside the radical. On the next radicand, I have two copies of x and a copy of y. In this one, it looks like the x comes out of the house, and the 2y stays home. On the next radicand, I have 4 times 3 times x, 2, 2, 3, and x. The group of 2 goes out, and the 3x stays at home. On the next one, we have 3, which is prime, x, and 2 copies of y. And it looks like the y comes out, and the 3x stays home. So before I try to add or subtract or combine like terms, let's clean this up slightly. 3 times x squared is just 3x squared, square root of 2y. The next one, 2 times x, well, that's really 2x squared, square root of 2y. On the next one, I have 4y times 2, which is 8y, times the square root of 3x, minus 1 times y, well, that's just 1y, root 3x. So I'm looking for like radicals. So the 2y, the square root of 2y is like, but not only do they have to be like, but our variable rules still stay the same, which means my variable and the radical part both have to be the same. Just like we talked about earlier, the variables have to be the same to add like variables, and the radicals have to be the same. So in this case, when you have both radicals and variables, you need to have them both the same. So these two look the same. X squared root 2y, x squared root 2y, and y times the root 3x, y times the root 3x, those are the same. So we have two sets of like radicals. On the first pair I have x squared root 2y, and all I have to do is add their coefficients. I had 3 of the x squared root 2y, and someone came along and took away 2 of them. That gives me 1 copy of x squared root 2y. Now, you don't really need to put the 1 there. You could probably erase that, and that would be fine. On the next group of like radicals, we have y squared of 3x. Both the variable and the radical part are the same. So then I'm just going to take the coefficients and add or subtract them. In this case, we have 8 minus 1, which is a positive 7. This is my final answer. Nothing else can be reduced, and nothing else can be added together because they're not like radicals. So on the next one, we don't have any coefficients on the outside of the radicals, which is nice, so I don't have to worry about that. But I will bring down the minus sign just so I don't forget. On the first radical, 250, that can be 25 and 10, and x and y and y. 25, that's 5 and 5, 10, that's 2 and 5, and 1 copy of y, x, and 2 of y. And I'm looking for groups of 3 this time, so be careful, you've got to look at the index. So I've got a group of 3 5s, but that's it. I don't have any other copies of 3, so inside the cube root, I'm left with 2xy squared. Then I have the minus. 54, that breaks down into 9 times 6, which is 3 times 3, and then 3 times 2, 1x and 2 y's. I'm looking for groups of 3, so the 3 comes out, and then the leftovers 2xy squared are the same. Now when I try to add, I need like radicals and variables. So underneath the radical, 2xy squared, the cube root of that, is the same. Yay! So that means they get to stay the same. The cube root of 2xy squared. But what do I do with the coefficients? I add or subtract them. In this case, 5 minus 3 is 2. That's my final answer. On this next problem, we have 4 over the square root of 3 minus 7 times the square root of 3. Now, step 1 says to reduce all radicals. In this case, root 3 and root 3, there's prime and there's nothing else we can reduce here. But step 2 says to rationalize any denominators if necessary. And we do have a necessary rational denominator. So what we're going to do is we're going to just take this over here to the side. I'll just do it down here. And just work on this one by itself. Then we'll come back, put it on the problem, and try to finish it. So I have 4 over the square root of 3. 3 is prime. I need to multiply it by some value in the numerator and the denominator so that I only have groups of, well, this is a square root, so I need groups of 2. I have 1 copy of 3, so really, in order for everything to come out of the radical, I would need 2 copies of 3. How many more copies of 3 do you need? Well, just 1. I had 1, I need 2, so I need 1 more. Whatever you do to the denominator, you need to do to the numerator. Looking back at the denominator, this 3 gets to come out because it is a group of 2. In the numerator, we have 4 square roots of 3. The coefficients on the outside, the 4 and the 3, they don't reduce at all. So it looks like that's the final reduction of 4 over the square root of 3. So I'm just going to go ahead and put that right back up here. 4 square roots of 3 over 3. And from the original problem, I'm still minusing 7 square roots of 3. And in order to add or subtract these, I need to have like radicals. Do I have like radicals? Sure I do. But I don't have, one's a fraction and one's a whole number, so it may be in your best interest to make that 7, a 7 over 1, so that we can add or subtract our coefficients. So in order to add or subtract, again, we need to do a little bit of work down here. So I have 4/3 minus 7 over 1. I need an LCD to add fractions or subtract fractions. So it looks like my LCD is going to be 3, which means I have to multiply the second fraction by 3 over 3. The first fraction I can multiply by 1 or just keep it. 4/3 minus 21/3 is negative 17/3. So that all of that work was just so that I could get the coefficient. And what happens to the radical 3 that was in highlighted here? Well, that stays the same. 17/3 can't reduce, and that is my final answer. On the next problem, 5 over the square root of 6 plus the square root of 24, step 1 says to reduce all radicals. So root 6 can be broken down to 2 times 3. That can't reduce. 24 can be broken down to 6 times 4, which is 2 times 3 and 2 times 2. Okay, this one can reduce. So even though 5 over the square root of 6 doesn't reduce, step 1 tells me to reduce what I can. So I'm going to take the 2 out, and the 2 and the 3 are going to stay home and multiply to get 6. So 2 square roots of 6. Step 1 is done. I have reduced all of my radicals. Step 2 says to rationalize any denominators. Oh dear, I've got a root 6 in the denominator, which means I need to rationalize that denominator. So I'm going to just bring this problem down here, see if I can't rationalize this first, and then proceed with the problem. When I rationalize the denominator, I can't reduce anything. 6 can be broken up to 2 times 3. So I'm going to multiply the numerator and the denominator by something in order to get groups of 2 because they're square roots. So because I have a 2, I need 2 copies to get it out of the house. I need 2 total copies, which means I need to multiply an extra copy here. For the 3, I have a 3. I would prefer to have 2 copies of 3. So that means I need an extra copy of 3. Whatever you multiply the denominator, you have to multiply the numerator. And when I multiply the numerator out, that's getting me 5 square roots of 6. 2 and the 3 can't come out of the house. In the denominator, it looks like the 2's get to come out, the 3's get to come out. No big surprise there. We chose it that way. So this is 5 square roots of 6 over 6. So I'm going to come up here and put that back in for 5 over root 6. So 5 square roots of 6 over 6. We still have to add that to 2 square roots of 6. Now, in order to add, I have to have like radicals. Do I have like radicals? Well, root 6 and root 6. Yes, I do. So because they're like radicals, I need to add the coefficients. 5 sixths plus 2, well, because 2 is a whole number, it might be better if we just made that into a fraction. So I have 5 sixths plus 2 over 1. If it was a whole number, I would just add it and move on. But because it's a fraction, I need to do a little bit of work here. I have to find an LCD so I can add fractions, which is 6. The first fraction I can multiply by 1. The second fraction I'll need to multiply by 6 over 6, which gets me 12 over 6, and that adds to 17 sixths. So, in my final answer, 5 sixths plus 2 over 1 is 17 sixths, but don't forget we still have the radical 6. Because it was like radicals, it stayed the same. And that completes this lesson.